Hello student, good morning to all. Today I am going to take lecture of 9th class, subject physics, chapter motion, and today is topic equation of motion by using graphical method. As you know, there are three equations of motion. There is three equation of motion. Three equation of motion. First, v equal to u plus at, s equal to ut plus 1 upon 2 at square, and v square u square plus 2as, where u is initial velocity or initial speed and v is final speed. S is distance and t time, and a is acceleration. Okay, so first we have to derive the equation first by using graphical method. Derivation of first equation. Of equation first by graphical method. So to derive the first equation by using graphical method, first of all we have to draw velocity time graph. As you know, velocity time graph, in this graph we have to plot a graph between velocity and time. Let this is x axis and this is y axis. The x axis denoted time and the y velocity. Okay, this x-axis represents the time and this y represents velocity. So this is the origin of graph. An vehicle moving with initial velocity u. So let this is OA. This is the uniform velocity with which object vehicle moving. After point A, the speed or the velocity of object start to increase with a uniform rate. This uniform rate is known as acceleration. It means after point A, the velocity start change with a uniform rate. It means there is a straight slope obtained. At this intersect at point P. Okay, so we have to draw a perpendicular that intersect the x-axis at point, let this point is C, and draw this line that intersects this point at B, and this point is E. So this is the graph in which OA equal to U. This is initial velocity. And OB equal to V, that is final velocity. And OC equal to AD. OC and AD are parallel and equal to each other. So this value equal to P. And this is the slope of this VT graph. As you know, the slope of VT graph represent acceleration. As you know, the value of acceleration A is equal to change in velocity upon time, and this is also equal to acceleration A equal to slope of VT graph, and this slope is equal to perpendicular upon base. It means this is equal to ED upon AD. How you can say ED upon AD is equal to A? Because the slope is represented by tan theta, and the value of tan theta is perpendicular upon base. So tan theta perpendicular ED upon AD, and the slope equal to acceleration. So by using this concept, we can say that the acceleration equal to slope of VT graph. It means A equal to ED upon AD. Okay. So I think the value of U, V, T is clear. So by using this graph, we have to find the first equation. Okay. So as you can see, OA equal to U and OB equal to B and OC equal to AD equal to T. So the value of acceleration, the acceleration of the body is rate of change of velocity. Acceleration equal to rate of change of velocity, and slope of straight line, the slope of straight line A in velocity time graph is also represent acceleration. Okay, so it means acceleration rate of change of velocity, and this is also equal to the slope of straight line AE. Slope of a straight line AE. AE in velocity time graph. In velocity time graph. So as you know, the slope is equal to perpendicular upon base. It means this is equal to ED upon AD. This ED, this line is equal and parallel to BA. Because you can see clearly ABDE is a rectangle, and as you know, the side of a rectangle is equal. It means AB equal to ED. So you can write this ED equal to AB upon AD. A equal to AB upon AD, and AB is given as OB minus OA upon AD. So by putting the value of OB, OA and AD, we can find a relation for acceleration. A equal to OB, OB equal to V, and OA equal to U, and AD you can write AD equal to OC, because this is also a rectangle in which AD equal to OC. It means OC is equal to T. So V minus U equal to AT. So V equal to U plus AT. This is the first equation of motion. So I hope you understand. So now I am going to derive the second equation of motion. Let a moving body cover a distance in time t. This is a time t, and a distance, some distance is covered by the body. So we know that the area under velocity time graph gives the distance travel or move by the body. Okay, the area covered by velocity time graph in time t is represent distance. You have to note this point. In velocity time graph, the distance travel, the area covered by velocity graph is represent distance. VT graph. Area covered in time t represent distance. You have to note this point. As you can see, an object is moving with initial velocity in this VT graph. An object moving with initial velocity u. After point A, there is uniform acceleration. It means a uniform rate with which the velocity start to increase. It means after that the velocity change with a uniform acceleration. Reach at point E. So this is your velocity time graph. So this area is represent distance covered in time t. So we have to find the value of this acceleration, this area to distance covered in time t. So it means we have to find this area, and as you can see, the area of this region we can find. This is the area of a trapezium. Trapezium OAEDCO. This is the trapezium OAEDC, and the area of this trapezium is equal to the distance covered in time t. So we have to find a relation between distance covered, initial velocity, final velocity, acceleration and time. So you can say the distance traveled in time t is equal to area of trapezium, distance covered is equal to area of trapezium OAECO. OAECO. This is the trapezium. Okay, I hope you understood. And this area you can divide into two small areas. You can see this is a right angle triangle, and this is a rectangle. Okay, so the area of this trapezium you can divide into two regions. The area of first area of triangle AED. Area of triangle AED. This is a right angle triangle, you can see, plus area of rectangle OADC. So the distance, as you know, the symbol of distance is S. So distance covered in time t is equal to area of triangle AED plus area of rectangle OADC. I hope you understand. It means we have to find the area of triangle OAD and area of rectangle OADC. Okay. So the area of triangle AED, or you can say this is ADC. This is a right angle triangle. So the area equal to 1/2 base into height. Base equal to AD and the height is ED. And AD equal to OC and ED equal to AB. Clear? And as you know, the value of OC is T and the value of AB, and this is OC, the value of AB equal to OB minus OA. Okay, I hope you understand. Now we have to find the area of rectangle ADCO. This is second equation of motion. So area of rectangle OADC, as you know, this is equal to length into breadth. Length into, this is the length AD into breadth DC. It means L into B. Okay. So this area AD equal to OC and DC equal to OA or AO or OA, because as you know DC is equal to OA. DC equal to OA, because this is a rectangle, and in rectangle the opposite side is equal. So it means this OC and OA. So the total area is equal to the distance. So let this equation first, second, and this is equation second, and this is equation third, and we have to put this value in F equal to area of trapezium equal to OA ECO. It means triangle OAET plus rectangle OADC, and this is equation first. So we have to put by putting the value of equation second and third in equation first. This is the equation first. Okay. So S equal to area of triangle 1/2 OC into OB minus OA plus area of rectangle ADC, and this is equal to OC into OA. Okay, so what is the value of OC? Triangle. This is triangle AED and rectangle OADC. So you can see this OC equal to P, OA equal to U, and OB equal to V. Okay, so by putting value, OC is T, OB V minus U, and OC P and OA is U. So S equal to 1/2 T V minus U plus UT. So S equal to UT plus 1 upon 2 v minus u into t. You can write this lesson. So by using first equation of motion, as you know, first equation v is equal to u plus at. So v minus u is equal to at. This v minus u is equal to at. Let this equation 4. So by putting this value, and this is 5th and this is 4th in equation 5th. So s equal to ut plus 1 upon 2 at into t. So s equal to ut plus 1 upon 2 at. This is second equation of motion. So I hope you understand. This is the second equation of motion, and the third equation of motion I will prove in my next video. So you have to try and you have to write in your fair notebook. Thank you very much.